parametric coordinates. Parametric coordinates are just a different way of describing graphs. Parametric, as the name implies, pair of measures. Pair of measures. Now we're used to doing things in Cartesian form, and that's when we describe the curve with one equation, but then the actual point with two numbers, our coordinates, an x value and a y value. Parametrics flips it the other way. The curve gets described by two equations, but that point gets represented by one number, which then gets substituted into the two equations to come up with the coordinates. That number is what we call a parameter. So here is y equals x squared, the Cartesian equation. A set of parametrics for this could be this. I mean, there's others you could have, but this would describe the same curve. X is t on 2, y is t squared on 4. T being the parameter. So a point there, let's say that's the point minus 1, 1, there's the Cartesian coordinates. Well, it would be the same as saying that's the parameter t equals negative 2. Because if you substitute negative 2 into those, you get negative 1, 1. And so every point, this one minus half a quarter, could be represented by a parameter, negative 1. But just like each point has different set of coordinates, they would have different parameters as well, the individual ones. So there's the origin, t equals 0, half a quarter, t equals 1, and you'll notice things like that. So even function, the parameter is opposite in sign, which is similar to what we see with the coordinates themselves. And there's t equals 2 for the point 1, 1. Okay, so how do we change from parametric form and get it back to Cartesian form? Basically, it's like simultaneous equations. You eliminate the parameter. That's what this is saying here. X will be some function of t, y would be some function of t. You eliminate that parameter, and then you'll find the equation of the curve. Here we go. X is 2t plus 1, y is 3t minus 2. Show this ends up being a straight line. Doesn't really matter which one we make t the subject in. They're both going to be just as easy as each other, I suppose. So I usually start with the x. So x is 2t plus 1, so t is a half of x minus 1. Sub that into the y. There's our equation, and it is something we recognise to be the equation of a straight line. Yes, that is a straight line. Ooh, what about this one? So theta is the parameter in this one. Not quite as easy to make theta the subject, so actually I don't. What I do is I use a trig identity, and you may recall this one, sine squared plus cos squared is always equal to 1. So that will allow me to eliminate the parameter. So rather than making theta the subject, in the first one I'll make cos theta the subject, and in the second one I'll make sine theta the subject. And I can substitute it into that trig identity we know. And there we get it. X minus 2 squared plus y minus 1 squared is 1, which we recognise is our circle, where the centre is at 2, 1. X equals sine theta, y equals sine 2 theta. The first thing we've been asked to do is to actually find all these points at those key points of every 30 degrees. There it is there. So when I find all those points, and then sketch our curve. Alright, well, there's the first point, there's the next one. Keep plotting those points in. What on earth is emerging? And if you're unsure, plot more points. It actually turns out to be, there it is, very interesting little shape. There's our curve. So what's its equation? Well, to eliminate the parameter on this one, I'm going to change sine 2 theta into, and this is what's known as a double angle result, which we haven't seen yet, but we'll see later on. Sine 2 theta is in fact the same as 2 sine theta cos theta. So I can substitute the x in and get rid of the sine theta. How on earth do I get rid of the cos theta? Oh, well, let's draw myself up a little triangle, because if x is sine theta, in other words, x over 1 is sine theta, opposite over hypotenuse, bit of Pythagoras, the adjacent is the square root of 1 minus x squared. Now I can substitute in for cos theta. It'll be the square root of 1 minus x squared over 1. Okay, well there it is with y the subject, but let's do better than that. I'm going to square both sides, and there, look at that. That's a nicer equation. 4x to the power of 4 minus 4x squared plus y squared is equal to 0. What a lovely curve. Okay, we're by H.